Hi everyone, and welcome to the talk about deploying ERC standards with Remix. And just to let you know what that means is we're going to deploy our first token using Remix. And what Remix is it's an online IDE, and you can see it here, and we'll get into this in a little bit. What it means is we can just code here right in the website if we need to code that much, and then we can deploy it to the blockchain right from here without needing to install anything else to do that. Now, you will need to make sure that you have MetaMask installed. So if you haven't already done that, please go ahead and download MetaMask. But otherwise, let's just jump right into it. And the first thing we're going to look at is deploying an ERC20 token. And this is a token standard used across most blockchains that are EVM compatible, such as Ethereum, Polygon, and Nervos Godwalken, which we'll be working with today. And because it's a set standard, that means virtually all applications on the blockchain know what to expect and how to work with it. It knows what functions and what events are likely to be there. So we want to work with this common standard that's well known across all different kinds of platforms. So just a couple of things about the ERC20 token standard before we start. ERC20 tokens are tokens. These are not coins. And what that means is it's a little bit debatable when we use the words here, but essentially coins are the native token of a blockchain. So for example, Bitcoin is a coin, and ETH for Ethereum is also a coin. It's the base issuance. It pays the gas fees, the transaction fees of the blockchain. So for Nervos, for example, and Godwalken, our coin would be CKB. So that's not really a token necessarily. So what we're going to be working on is our own tokens. And so tokens are pretty cool because we can deploy sort of essentially our quote unquote our own coin and program our own rules and have it act the way that we want it to be. Now, one thing I would also note here is token doesn't necessarily have to be monetary. So for example, in the context of a game, we're going to be working with gold, and I'm going to deploy a contract for gold. However, again, you don't necessarily need to let that limit you into what you think it could be used for. But I do want to point out the difference here between fungible and non-fungible. And so ERC20 is a fungible standard, meaning it's uniform, it's interchangeable, it's divisible, and then it gives some examples here of what that could be. So the ERC721 format is essentially what we would call an NFT format. NFT standing for non-fungible token. And that means each non-fungible token is unique. We can't divide it, and they're not interchangeable directly. So here's another little picture, and we can see on the left-hand side, fungible, it's like $1 equals $1, 1 Ethereum equals 1 Ethereum, like 1 ETH is 1 ETH, 1 Bitcoin is 1 Bitcoin. Like basically we can swap these out and they equal each other. A non-fungible token is we have these two, for example, maybe these are crypto kitties, where each kitty has its own unique value and characteristics, and therefore we can't say that these two are exactly the same, even though they follow some kind of standard. For example, maybe they both have a value of color, or it would be a key of color and a value of black, and a key of color and a value of orange. So they're not exactly the same, even though they do follow a standard. So here we have two tickets, a front row and a back row. So again, they are both seats, but they have different values in them, or houses. So these are essentially what we'd consider NFTs, and this is what we'd consider, quote unquote, a token. So with all that being said, why don't we just jump into actually developing something? And I think as we go along, it will become more and more clear. And where we want to start here is by using openzeppelin.com. And openzeppelin.com has a lot of base contracts for us to use and start with, so we don't have to rewrite everything over again to use the standard. Because if we want to use the ERC20 standard, it would require us writing like a lot of code ourselves to make sure we have all of the minimum functions to meet that standard. So by using OpenZeppelin, it basically gives us everything we need out of the box, so we meet the minimum standards automatically, and then we can just build on top of that as necessary. So from here, I'm just going to choose contracts under products and get started. And if we look down the left-hand side, we have information about the ERC20, ERC721, 777, and 1155. So we won't get into all that. We'll just stick with ERC20 and ERC721. And it gives us all kinds of information about the contracts or things we can do. But this beginning stage, we're just going to use the wizard here at the top. And the wizard is just going to help us start our code a little bit faster. And let's just ignore the code part here to begin with, and we'll just look at the settings on the side. And we can give our token a name. And I'm just going to call mine gold, just to keep things really simple. And most tokens have a 3, sometimes 4-letter indicator of what it is. And I'm just going to call this GLD for gold. So this is usually used on DEXs or other exchanges to identify quickly what is your token. Now, we're also going to say on the features, I want this to be mintable. So I want people to be able to mint or essentially make tokens and add it to their wallet. And because of this, we need to have this access control set as ownable. So we can see here it imports the ownable contract, and we'll talk about this more later, but it means that people can own this gold token. So there are other features here, but we won't be using any of them, such as being able to burn tokens, pause, permit votes, flash minting, snapshots. And we can really make this, so-called programmable money or tokens to act in all kinds of different ways, which can make some really interesting features. But again, for now, I just want to stick to the fundamentals of what we're doing. So we're just going to set it to mintable. And on pre-mint, I can set how many tokens will go to the contract creator's account. So that's us. We're using our account to deploy this contract on the blockchain. So I want to give myself a memorable number, just easy to read. So I'm just going to say 999, just so we can see it easily in the contract. Okay, so we basically have this whole contract done. And if we click open in Remix, it should open in Remix and have this here. Unfortunately, I find this doesn't work well for me for some reason. So I'm just going to go ahead and copy and paste this out. And you can click this link just to open up Remix for you. And let's just see what happens. I'll click it anyways. At least it has the link to Remix so we can find it, but it will be remix.ethereum.org. And I do have, let's see here, we want to be over on this far left-hand side and start at the very top. It has these 2 little files. And this is essentially our file structure. Okay, and I do see a contract that's been added here, but if for some reason it hasn't been added for you, I'll just delete this. We can go into the little plus button next to workspaces and go create. We can use a default, or we can just choose a blank one. It doesn't matter. The workspace is anything you want. Just say OK, and it's going to create a new workspace for you. Now, once I'm here, I'm going to go create a new file, and we can give our contract whatever name we want. This really doesn't matter. So I'll just call this my ERC20 token. But we need to make sure it ends in .sol. This is for Solidity, the programming language we're using to make this. Once I'm in here, I'm just going to paste this in. And it may take a moment to figure stuff out for you. But so far, it looks OK for me. You might see some things like popping up here as it tries to load stuff in. Okay, now we're ready to actually take a look at the code, and we're not going to make a lot of changes. First, we're just going to look to see what exists already, and Again, I don't want to deep dive too much. I just want you to know what we've going on so far. So at the beginning of all Solidity contracts here, we should have the licensing for this contract. So here we have it just under the MIT license. And if you're new to writing, Solidity contracts, this kind of stuff you just want to copy and paste in so you don't make any syntax errors here. The next thing it's going to have here is pragma solidity, and then it's going to give the solidity version that we're using for the compiler. Again, I would just stick to essentially copying and pasting in the compiler versions, and we'll look about this more in a minute. But Solidity is a compiled language like C#, so once you write your code, it does need to be compiled before it can be deployed to the blockchain. Next here we have import statements, and this is essentially using inheritance. So this is bringing in behind the scenes the ERC20 standard and the ownable. And you can see here at the top, we say contract. So this is the entire contract is in here. Gold is ERC20, comma, ownable. So this is bringing in, it's importing these for inheritance. Now, if you're more familiar working with C#, it might look something more like this, which for my eyes is much easier to read. And then we essentially have a constructor. So this is very similar. And we are passing in the values of gold and GLD. Now, in our constructor, we can see that it's calling the mint function, and it has the message.sender as the first argument. So the message.sender, this is the person who's calling the contract's address will come from this. Because we are the ones deploying the contract, we are the ones setting this constructor. So the constructor will only ever be called by us when we deploy the contract once. So the next thing here is we have the number of tokens that are being given to minted to this message sender. That's us. And you might notice right away this is like a very weird syntax. But this is, the quote unquote correct way to set the number of tokens because they're divisible by 18 decimal points to this side. So actually, I believe behind the scenes, this is calling 18. And really, I wouldn't focus on worrying to trying to understand this so much, just as to remember that this number here is essentially the number of whole tokens that you're distributing. So if I wanted to just give myself 3 tokens on mint, it would just be like this. So I just set 999, so it's easy for us to see what's going on. So this mint function is being inherited from this ERC20 contract. So even though we don't have our own, it's being called behind the scenes here. So we have a mint function here, but you can see this is not an underline mint. This is just mint. So even this mint function is calling the internal mint function, which always has a 2 in the amount. So this is the 2, and this is the amount. Okay, the next thing we have here is this function. And we can say all functions are defined first by saying function and then a name. And then we're passing in whatever arguments are necessary here. So this is the address is the variable, and we're giving it a name of just 2. So this is arbitrary. It could be anything we want, just like C# essentially. And the address will take a address format of an account. So whatever your Ethereum account or Godwoken account, whatever it is, we're telling it who to pass, and then the amount. Now this is marked as public, so this means this is a public function. And again, in C# it's a similar way. This means it can be called directly from outside of this contract and to use it. The interesting thing here is we have an only owner decorator for this function. And if we add only owner here, it means only the owner of this contract is able to call this function. And in this case, it would be us because we're deploying it. So in this case, this is probably not what we want for our game, because even once we deploy this contract, we're the only ones who can mint more tokens. And that means anyone who's playing our game, we essentially have to mint and send them tokens, mint and send them tokens, and mint and send them tokens. So that's not really going to work for us. Now, if we go to the website startwithnervos.com, and this is our developer portal, and it's still being worked on, but we go to launch on Godwoken because this is the network that we are launching on for this hackathon. This is the Nervos Layer 2 EVM, and it has all kinds of information here you can read up on. But we want to scroll down and go to the Nervos Layer 2 EVM training book. So we can click on the training book. And we scroll down, and under the ecosystem here, we have test tokens. I hope we have test tokens. Okay, there we go. And we have pre-deployed this contract for you. So while you're watching this, if you're not able to deploy this, or if you're not able to do this, you can use the contract that we have pre-deployed for yourself. However, I would like you to keep watching along and learn a little more about this contract that we deployed, and I would encourage you to deploy your own contract. So this one essentially will be shared by everyone's game. So you will have tokens in common with other people's game. But you can also, again, I encourage you to try and launch your own. So what I'm going to do, though, is just copy this out. And I'm just going to grab the functions that we don't have and I want to add in. So we're going to keep the constructor, but we're going to override this min function and create a custom one here. So let me paste this in. And I'll move this private variable to the top, which is, the custom. And now we have two different functions here. So we have one called claim tokens, which essentially is our new mint function. We just gave it a different name to be clear that it's not the same. And we have a function that has claimed. So this will help us check to see if anyone hasn't claimed anything. And what we want to do here is limit the claim of tokens to each account just once. So this means each account, each MetaMask account, or whatever it is on the blockchain, can only claim tokens just one time. And for a production level game, this is probably not the best choice because someone could open up like 15 accounts and all just get tokens and pool them together, and then they'd have a whole bunch of tokens. But in the context of the hackathon here, the game jam, whatever we want to call it, I think this is just a good way to do it that someone doesn't get too many tokens too quickly. There's different things we could do, such as selling our tokens or giving them away under certain circumstances. But for now, just to keep things simple, we are going to just allow people to claim their tokens once. In order to do that, we need to keep track of a list of who has claimed their tokens, right? So this is saved on the blockchain, and this variable type is a special variable type for Solidity called mapping, but essentially it works like a hash table where we have a key value pair. So the key being the address or the account address that claim tokens, and a bool to say yes or no they have or have not claimed tokens. So we can also set this to private, and then we give it a name. As you can see, the private is farther. It's not at the beginning, but it's sort of in the middle here with Solidity versus C#. And we don't need people to check this directly. We have a function down here for people to check. Okay, so let's see how this works. So again, we have a public function here. So function, then the name of the function, and it's set to being public. As you can see in this case, it's not only for owner. Anyone can call this. The next line here is essentially what I like to call a gate check, where it says, hey, require this to be true before you keep moving through this function. If this isn't true, then it's going to boot you out of the function. And so right in this first half, we are requiring this bool to be true. And what's the bool? Well, we are checking this variable right here. And so we're going to pass it the address of the person who's calling this function. So I'm calling the function and saying, hey, I want to claim my tokens, and automatically it passes my wallet address. So how do we get that wallet address? Well, where the message sender will give us the address. So we check this variable, pass it in the address, and it will give us back true or false. Okay. And if we get caught by this gate check, it will pass back the message, you can only claim tokens once per account. So if we're able to get past that gate check, then we need to set the value of token claimers variable mapping, so that next time we can't get the tokens again. So we just say this variable name, we pass in the address, and then we set it to true. Lastly, we want to mint the tokens to that individual. So we give the number of tokens, and then, we give the address and then the number of tokens. So in this case, they are getting 100,000 tokens. And again, you see we've got this times by 10 by 18. So this is just the decimal places. Okay. Lastly, we've added a convenience function here that says, let people check if tokens have been claimed for an account. And anyone can call this. You can't only, it's not only checking just for your own account, you can check anyone's account. And to do that, we have to pass the account address that we're checking. And again, this is a public function. And what's interesting is a little bit different here is this is a view function. And what this means is it's just reading from the blockchain. It's not writing in any way. So this makes this free. It's always free to read from the blockchain or from most blockchains, such as Godwoken, but it's not necessarily free to write to the blockchain. We also have the keyword here returns, because we are returning a value, and we have to define what the value type is, or the variable type. So in this case, we're returning a bool. And just like in C#, we're just going to use the return keyword, and then we're going to return the address here, return the true or false. So to get that true or false, again, we're just using token claimers and then passing in the address, and this will return true or false. So at first, this might seem like a lot because you're not necessarily familiar with how the functions are structured and sort of the rules of solidity, but it's fairly quick to pick up if you are already a programmer, given a little bit of time. I think one of the more tricky parts is writing contracts that are not essentially faulty or somehow leave you open to any kind of exploit. And the best way to avoid that at the beginning is especially to start off using these contract wizard contracts and using Solidity's, OpenZeppelin's inheritance methods, because it adds all kinds of methods and functions behind the scenes. Now, this is the GitHub repo, and you don't need to necessarily check this out. This is just informational. And we can see this is the ERC20 standard. And if we look, there are all these kind of functions that are behind the scenes here for us to use, such as checking the total supply. We can check the balance of an account. We can transfer our tokens from our account to someone else. And these are sort of all added here by inheritance behind the scenes, so we don't need to program them, which reduces the risk of us essentially messing something up. Okay, all that being said, now we're done this contract, and we're going to go ahead and compile it. And we're going to double check at the top. We are using 0.84, which is a fairly modern version. We can go on the left-hand side. We don't need to search anything. We're going to go to the compiler. And I'm going to change the compiler version to match. Potentially, you could use other compiler versions and it wouldn't necessarily be a problem because maybe all this is within that version. But there's always a chance that it won't be. So you're best off just at the beginning, always choosing the compiler version to match your Solidity version up here. And then we can click this and it will compile here on the website for us. How this. Okay, there we go. And we should have a little green check mark here. The next tab down here is the deployment tab. So just because it's compiled doesn't mean it's actually deployed to the blockchain. And we can actually deploy it locally on this machine. Essentially, it's on the cloud. And we don't need to change anything here. We'll just choose JavaScript VM London and just click deploy. And okay, it's saying here that I didn't necessarily inherit these things. Okay, and yeah, I caught the reason it was importing these contracts. The reason that it wasn't working is because my contract was set to the ownable contract, which is just an abstract. I needed to make sure that I'm down here on the gold my contract and deploy that one. And then once that happens, just fine. Now, what it's done, I've deployed 2 copies, is it's deployed again on this local cloud. And we can open up and see, once it's deployed, all of the functions here that are public on the left-hand side. And we have 2 colors. So one color is orange and one color is blue. Now, the blue colors are read-only functions. They simply read something from the contract. So we can click total supply, and it will read from the contract and give us the total supply that has ever been minted out of this contract. And you may not be able to see it down here. It's a little bit small, but it says 999, and then it has 18 values behind it. So this is the one that was minted in the constructor. We could also click name, for example, and it would give us the name gold. Now, on the other side, these orange ones are essentially our read and write functions typically. They have some type of write to the blockchain. So for example, we could click claim tokens, and it's going to be this function right here called claim tokens, which in the process mints something, and it also is behind the scenes adding up how many our total supply is. It's also setting our token claimers to true, so it has some sort of writing to the blockchain. And I'm going to go ahead and click that. And now if I go down to the very bottom and click total supply again, it may be hard to see here, but it's, I probably can't read this number, but it's 100,999 with 18 decimal points after. So you can see the total supply has gone up. Now we want to make sure that we can only claim this once. So if we click claim tokens again, at the very bottom, it throws an error here, and you can see a red X. And again, it might be a little hard to read, but it says the transaction has been reverted to the initial state. Reasons provided by the contract. You can only claim tokens once per account. So this is our error message here. So now that we can see that it can only be claimed one time. Okay, so awesome, it's deployed locally, but we actually want this to be deployed on Godwoken so that we can use it in our game. So we're going to change the environment down to be injected Web3. And this is going to inject from our MetaMask. And to do this, we want to make sure that we are on the right network. So I've got my network set to Godwoken test version 1.1. And we want to make sure that it's connected. So we can see this is, it says we have 2 connected to it. And so for example, disconnect this one. So I only have this one connected, which is my Godwoken dummy account. Now, when you switch to injected Web3, if you don't see an account pop up here, make sure you go over to your MetaMask and click and open it up. And again, make sure that you are on the Godwoken dummy testnet. Or sorry, it doesn't need to be dummy. It just needs to be the Godwalken testnet version 1.1 or 1.2, depending on when you watch this. After that, we should be able to click deploy, fingers crossed. And once again, MetaMask is going to open up and it's going to ask us if we want to confirm this contract. And to deploy contracts to blockchains, normally it costs a gas fee. You have to pay a fee. However, launching to testnet currently is free, so we don't need to use any CKB. And we will click confirm. If we open this up once again, we should see here that this transaction is pending. We can see contract deployment, pending, and then the website, remix.ethereum.org. Cost is 0 CKB. Now, I got to be honest, at the moment, this process can take a while on testnet. On mainnet, it shouldn't take this long, but this is just, again, sort of the free testing network for Nervos Godwalken EVM. So we'll just hang out a while here until this deploys. It can take sometimes a few minutes or 10 minutes, so we'll just cut forward. Okay, cool. That didn't take too long. It only took about 3 minutes. And you can see here that the contract deployment has gone through. There's no more pending. And if we check down at the very bottom here and we click this little down button, it gives us some information about this. So it says from which address was this deployed. So this is 0x77. And if we go back to MetaMask, we can find our address up here. And we could click to copy to the clipboard, but we can see it starts with 0x776. So we know this has been deployed from our account. And we can also see the transaction hash. So this means it gives us a transaction ID, so we know where it occurred on the blockchain, and we could potentially use this to look things up later. If we open this up here on the side, now we actually have all of these functions, and all of these functions are actually occurring on the Nervos Godwalken blockchain. So let's click total supply, and it made an actual call to the blockchain, and it says 999. Now let's claim our tokens. And because this is a write function, and it might cost us gas fees to do a write function to the blockchain. However, again, this is free on the testnet currently. The estimated gas fees are 0. So we're going to sign this transaction. And again, it might take a minute or so here because Remix is not like super fast at the moment. Okay, there it goes. We can click this little down button and it will show the details. But it says that it was successfully completed. And if we just call the total supply again, which is much quicker because we're just reading from the blockchain, not writing, so it doesn't cost us anything, or it doesn't cost us any gas anyways, we can see the total supply is down here. Now what we want to do is make sure that we copy out the contract address by clicking copy and then pasting this somewhere for ourselves, because we will need this contract address in order to call it from our game. Because even if we want to call this function, say, claim tokens, we need to tell it to which contract to look at to claim those tokens. So don't forget to copy out here your address. Now, if we go back to start with Nervos, wherever that is, so we are at start with Nervos, Godwalken, we can see that we have 2 testnet explorers. So this shows all of the transactions, purchases, all that kind of stuff that happens on the testnet blockchain. I'm going to open them both up. So I prefer Block Scout, but every once in a while it's down. So we have an alternative here. And let's just paste our contract address in here and push enter. And we can see here that it's on the blockchain. The token is called gold with GLD. And there's a transaction success here 5 minutes ago. And so this is still fairly new. It may not show us all the details that we're looking for, but at least we know that it's been deployed successfully, and we can see, when and where it was on the blockchain. So here's the logs. So let's try the GW scan and see this one here. Also click enter and see, okay, yeah, so 5 minutes ago it was deployed, and we could see which block it was on and the transaction hash and all this kind of stuff. So this is essentially the receipt. Okay, so I think that's a really good place to end here for the ERC20 token. We basically deployed our first token on Remix. We've got the address to use in Unity or wherever else we want. We know the names of our functions that we might want to call here, which is, again, sort of keep a record here of your contract somewhere, maybe copy it out, just so we know what the functions are here, which is claim tokens, or this isn't, yeah, claim tokens and has claimed. Okay, thank you, everyone.